Let's look at this simple equation and solve for x. Now, just by looking at the equation, you automatically know the answer is going to be 10. But understanding the technical way of solving a simple equation is going to allow you to apply the same concept to more advanced ones. Now, if you're intimidated by the x's in any equation, just remember, the x is a variable. So basically, it represents the unknown. It can be a symbol, it can even be replaced with a heart, and you just solve for its value. Basically, there is a number here that is disguised. It's basically like wearing a mask, and we're going to solve for its value. So don't let any x's or y's or any other variable intimidate you. When solving for a variable, you need to isolate it so that the equation ends up looking something like this. So in this case, because we know the answer, I'm just going to show you x is equals to 10. That's basically what we're trying to get at. We're trying to have the variable on one side and the solution or answer on the other side. So we're going to try to keep the x on the left, and our goal is to move the 5 over to where the 15 is. Now, how we're going to do this, I'm going to explain it using two ways. The simple rule is when you have additions and subtractions, in this case, we have an addition of 5, you move it over to the other side, and once it crosses the equal sign, which I'm going to refer to as the bridge, you need to change its sign. So we're going to take the 5 and move it over to the 15. X is equals to 15. And because we're moving the 5 over the bridge, we're moving it over the equal sign, it's going to change its sign, and it's going to become minus 5. So in this case, you can continue solving, and it's going to be x is equals to 15 minus 5 is 10. So the plus 5 became a minus 5. And if I continue the analogy of the equal sign being a bridge, you could think about it as the fee that the number undergoes in order to cross over. Now, the second way I'm going to explain this, aside from the analogy and why did the 5 change its sign, and I'm going to show you in my explanation here, you probably have heard the term, what you do to one side, you must do to the other. And that's to ensure that the equation remains balanced. So again, we have our x plus 5 is equals to 15. In this case, we want to remove the 5 from the left side. And to do that, I can simply subtract 5, right? Because 5 minus 5 is going to zero out, and I'm going to eliminate the 5. And what you do to one side, you must do to the other. So I also have to go minus 5 here. And again, that is to keep your equation balanced. What you do to one side, you must do to the other. Minus 5, these cross out, become 0. So now I have x is equals to the 15 minus 5, which is 10. This is good for your understanding of the methodology, but really the shorthand way to remember it can be applied to even the longer equations where the number changes its sign when it crosses the equal sign or the bridge. And this again is for additions and subtractions. Let's look at an example now where we're starting with a negative number. So the equation here is x minus 2 is equals to 6. And I'm going to speak in the shorthand method. So x minus 2 is equals to 6. What I have to do is I need to move the 2 over to the other side in order to isolate for x and solve for its value. So I'm going to have x is equals to, and I'm moving my 2 over, and it's a minus 2, so it's going to become a plus 2. X is equals to 6 plus 2, that's 8. And that's how I know that x is equals to 8. Now, of course, this is a very simple equation. So just by looking at it, you probably already knew that x is going to be 8. But if it was a little more complicated, what you would do is to check your answer, you would sub in the value of x is equals to 8 into your original equation. So my original equation was x minus 2 is equals to 6. I'm going to replace the x with 8, right? Because that's the value we solved for, 8 minus 2. And that does give me 6. So I know that my answer is correct. Of course, it seems silly because we have a very simplified equation. But again, the goal is to understand the basics of how to solve such equations and apply it later on to more complex ones. Now, what if we have an example where there is both addition and subtraction? Well, we have x plus 2 minus 1 is equals to 6. Now, it would be too silly to move each of the 2 and the 1 by themselves over to the other side. What you must first do to make your life easier is collect like terms. And what does that mean? That means we know that we can already solve this. So x, 2 minus 1 is 1. So then, plus 1 is equals to 6. You see, these are like terms, and by collecting them, we have 1. And now we're back to an equation that's similar to the first one we did, where we can just do x is equals to 6 minus 1, right? Because you're moving the 1 over, and it's going to change its sign. And now we know x is equals to 5. And again, if this was a little more complicated, we would have, and if you have time, especially on a test, you would check your answer by subbing in the value of x in your original equation. So our original equation was x plus 2 minus 1 is 6. So that's basically saying 5, right? Because we solved x was 5, plus 2 minus 1. So 5 plus 2, that's 7, minus 1, it's 6. Now let's look at another equation, which is slightly longer, but still relatively simple. In this equation, we have what we call like terms. These are numbers or variables that we can combine and start solving for to help compress the equation, so to make it shorter. So that's the first thing we're going to do, is we're going to collect the like terms. So in this case, we have an x. And remember, when there is no coefficient, and the coefficient is always the number preceding the variable. So here, the 3x, the coefficient is 3. When we have no number in front of the x, there really is an invisible 1. So it's like 1x. So we have 1x plus 3x. Those are the like terms, which is going to give us 4x. The other set of like terms is the minus 2 and the plus 4. So I'm just going to circle the 1x and the 3x so you know we're done with them. And then we have the minus 2, don't overlook the sign, and then the plus 4, which is going to give us plus 2. So after collecting the like terms in our equation, it's now compressed to 4x plus 2 equals to 10. From here, we'll solve the same way we did the shorter equations. I'm going to keep the x on this side with its coefficient, right? Because those are being multiplied. We're only going to move over what's being added or subtracted. It's equals to 10. And what did we say happens when we move the 2 over the bridge? You got to change its sign to minus 2. So now we have 4x is equals to 10 minus 2, which is 8. Now, we know 8 is the value for 4 times x. We're trying to isolate for only 1x. So our goal is to make the coefficient of the x 1, because we want to know the value of 1x, not 4 x's. And we can do that by dividing by 4. Because once you divide by 4, 4 divided by 4 is 1. We're going to go back to having 1x. And what you do to one side, you must do to the other. So if we're dividing by 4 here, we're going to divide the other side by 4. So now we have x with the invisible 1, right? So 1x is going to equal to 2. Sorry, I'm writing a little slanted. X is equal to 2. And from here, now that we have the solution for our variable, we can check our answer by subbing the answer back into our original equation. So our original equation was x minus 2 plus 3x plus 4 equal 10. The x we're going to sub in 2, minus 2 plus 3 being multiplied by the value of x, which is 2, plus 4. Let's see if it's going to equal 10. So 2 minus 2 is 0. 3 times 2, that's 6. 6 plus 4 is 10. So we're good, right? These zero up. This becomes a 6. Plus 4 is going to give you the 10. I hope you found this video helpful. If there are topics you want me to cover or prioritize, please leave them in the comments.